Hi everyone, I'm Professor Rad, and today we're going to do a left-tailed hypothesis test. So I reviewed these steps in the previous video, but I thought I would review them again, just in case you're looking at this video first for whatever reason. So we've been doing the pieces of hypothesis tests so far, but now we're going to put all those pieces together and conduct a full test. So our steps to conducting a hypothesis test. First, you want to make sure that you can do it. So in order to do a hypothesis test, we need to have a simple random sample, and we need to have either a sample size more than 30 or an approximately normal population. These are the same conditions or similar conditions to our central limit theorem, so that's what's sort of the structure behind this technique. So that's why we have to make sure we have that. Then we're going to collect our usual information. So this is going to be a population mean and a sample mean, a standard deviation, and a sample size, and our level of significance. Then we got into the work here. So we basically have stating our null and our alternate hypotheses, a four-words central limit theorem problem, and then stating our conclusion by comparing the p-value to alpha. And as part of that four-word central limit theorem problem, we're going to find a z-score, draw a picture, and then get our p-value. And the p-value is just the proportion, percent, or probability that we've found before. So if you prefer sort of a more visual layout of this information, that's what I've got going on here. So we've got a presentation of our checks that we've got an SRS, and we've got an appropriate sample size or normal population. Here's the info that we're going to want to collect. And then I have sort of a separation of the different steps depending on the type of question we're doing. So in this video, we'll be following the left-tailed steps here that we've got on here. And then we'll draw our conclusion based on whether the p-value is less than alpha or more than alpha. So let's go ahead and get started with this first component. So we'll do our checks and collect information, and then we'll jump into the left-tailed steps after. Oops. All right, so let's take a moment to read through the problem and familiarize ourselves with what's going on. It says, Amelia wonders if families in Utica, New York are smaller than the typical American family. She surveys a simple random sample of 60 families in Utica and finds a mean of 3.04 people per family. According to 2014 census data, the mean number of people in an American family is 3.13. Assume that the population standard deviation is 1.78 people. Conduct a hypothesis test at the O5 level to determine if you can conclude that the mean number of family members in Utica is less than the American average. Okay, so to do the hypothesis test, we're looking for a simple random sample, which I see right here. And we need either a normally distributed population or more than 30 members in our sample. And our sample was 60 people, or 60 families rather. So yes, we can do a hypothesis test. All right, now I'm going to go through, and to help me collect the usual information, I'm going to highlight in some different colors here. I'm going to use yellow, I think, to represent my hypothesis test information, and let's use green for population and purple for sample. Let's try that. So Amelia wonders if families in Utica, New York are smaller than the typical American family. So in this first sentence, even though it just seems like it's providing context, some of this context is actually important. She wonders if they are smaller than the typical American family. So whenever you see a comparison about greater than or less than, that's going to be an important piece of information. She then surveys an SRS of 60 families in Utica and finds a mean of 3.04 people per family. According to census data, so remember census is population, the mean number of people in an American family is 3.13. Assume that the population standard deviation is 1.78 people. We're going to conduct a hypothesis test at the O5 level to determine if we can conclude that the mean number of family members in Utica is less than the American average. Okay, so let me just put my tops back on my highlighters here so they don't dry out. And then let's summarize this information we have. So this purple information, this is our sample information. So the sample size is 60, that's N. So we have 60 families. And her sample had a mean of 3.04 people. So sample mean is X bar. So we're going to have 3.04. And I'm going to abbreviate people with PPL. Then in green, I have the population data. So according to the census, the mean is 3.13 people per family. And our standard deviation is 1.78 people. Lastly, in yellow, I have the specifically hypothesis test information. So our significance level is 0.05. So alpha is going to be 0.05. Okay, so that is summarizing the information. Now let's state our null and our alternate hypothesis. So Amelia is comparing families in Utica to typical American family. So her null hypothesis is going to be based off of the typical American family of 3.13 people. So her null hypothesis is that mu is 3.13. Now her alternate is based off her suspicion, and that's why I had words like smaller than or less than highlighted, because that speaks to what Amelia suspects. She suspects that the mean in Utica is less than 3.13 people. Okay, so once we've identified that this is going to be a left-tailed test, we're going to want to take out our left-tailed steps here to kind of guide us. So in a left-tailed test, this is where you suspect that your mean is smaller. And so we have our alternate that mu is less than, which is what we have here. Now, we're going to find our z-score using the formula x bar minus mu times the square root of n all over sigma. So z is going to be, using my collected information, x bar 3.04 minus mu, which was 3.13, times the square root of n, so n was 60. And then we're going to divide that by sigma. So sigma is 1.78. Now, if you watched the two-tailed test before, we had a plus minus in front of z, and that's because the test we did before was for a two-tailed test where you have that plus minus. That's not the case for a left-tailed test, or for the right-tailed test for that matter. So that plus minus is only for a two-tailed test, because in a two-tailed test, you should get two z-scores because it's two tails. All right, so let's go ahead and find our z-score here. We're going to do 3.04 minus 3.13 times the square root of 60. And then we're going to divide that by 1.78. And our z-scores get rounded to the nearest hundredth. So we have a negative 0.39. All right. Now, as a test in our directions here, it tells us that z should be a negative number, and we did get a negative z-score. So this is a good kind of check to have. Next, we are going to draw the picture. of our standard normal curve. So negative 0.39 is indeed to the left of 0. And we're going to shade to the left because we do think it's less than that. Now to get the p-value, we're going to look up our z-score on our standard normal curve table. This one here. So we have a negative 0.39. Let me zoom in a little bit here so we can see better here. So we've got a negative 0.3 and then all the way over to 9. So I have 3483. So now I'll never get back to where it was, but you know, 0.3483. Okay. Now, as per my steps, we looked up our z-score on the table, and then the p-value is that table value. And that makes sense with our forwards problems from before. When you shade left, whatever you get from the table is going to be your area. So we have 0.3483. Whew. And then lastly, we're going to draw our conclusion. So artistic to draw a conclusion here. Let's compare our p-value to alpha in order to do that. Our p-value is 3483. And alpha up here was 0.05. And as I compare them, they differ in the tenths place. Our p-value is quite a bit bigger than our significance level. So when I draw my conclusion, I'm going to be following my second set here, my p-value greater than or equal to alpha. So when your p-value is greater than or equal to alpha, that means we're going to fail to reject the null hypothesis. Since the results are not statistically significant, at the 0.05 level. And then we have to figure out, what can we conclude? So we can conclude that whatever you were told, your null hypothesis, may be true, and we can't conclude our suspicion. So let's come back up to this problem here. So we can conclude that the null hypothesis may be true. So the null hypothesis is that there's a mean of 3.13 people. In this problem, Amelia is comparing families in Utica to the typical American family. So what we're finding here is that the mean in Utica may equal the mean for the typical American family. So we are able to conclude that the mean family size in Utica may be the same as the typical American family. So again, we have to use the slightly wishy-washy language of may be. We can't declare definitively that it's the same, but our evidence is supporting that it may be the same. All right, so that is going to wrap it up for this video. In the next video, we will do the last type of hypothesis test. We'll do a right-tailed hypothesis test. So I hope you found this video helpful, and I look forward to seeing you in the next one. Bye for now, everybody.